Hello, my name is Nigel Thurlow and I'm the CEO of the Flow Consortium, the home of the Flow system. There is a great deal of buzz in the world about artificial intelligence currently, so I thought it might be useful to create a simple primer video aimed at executives and leaders to understand all the jargon and to imagine the opportunities as well as assess the risks. In this video, I will cover all the basics of AI and its associated terminology and its vocabulary. However, this is not a deep dive technical video and is designed to help leaders that are new to AI to understand what it is, what it's capable of, and what the vocabulary is. Oh, and just in case you're wondering, you are not watching me. You are watching my digital twin. Welcome to NigelBot. The powers of AI, it seems, are endless. Okay, so let's familiarize ourselves with some basic terms first. Mechanization refers to the replacement of human power with mechanical power of some form, but automation is the replacement of human judgment. Now, automation and mechanization are often confused with each other and wrongly used as synonyms. Mechanization displaces physical labor, whereas automation also displaces mental labor, thinking if you like. Automation can also have the attributes of mechanization, but mechanization is just that and has no intelligence. Automation is the replacement of human thinking with computers and machines. Automation tends to create jobs for skilled workers at the cost of unskilled and semi-skilled workers, and it affects many industries at the same time. Interestingly, the word automation came from a vice president of Ford, a man by the name of Delmer Harder, when he once said, "What we need is more automation." I'd like to introduce you to Sakichi Toyoda, the founder of what became the Toyota Motor Company. He was an inventor and known for creating the world's first automated weaving loom, known as the Type G loom. This loom was renowned for some of its capabilities, such as the ability to stop itself when a thread broke and alert an engineer that it needed attention. Now remember, this was 1924. Sakichi said that we must invest in machines with a human-like intelligence. Only if machines have intelligent functions, Jidoka, can we really get them to do useful work for us, otherwise we end up serving the machines. That was quite some foresight given the era it comes from. Let's look at that word Jidoka that we saw on the previous slide. Jidoka is the Japanese word for automation, but Toyota took it and tweaked it a little. They added the symbol for human, but squished it against the central character. This was to illustrate that automation should always have the human touch, and the Toyota version of Jidoka was therefore born. A made-up word, autonomation, was coined by John Shook, a former leader at Toyota and former chairman of the Lean Institute. Artificial intelligence has been described as machines thinking and working like humans, or the simulation of human intelligence processes by machines, especially computer systems. But be careful. Simply automating existing processes using computers, known as RPA or robotic process automation, may simply make you more efficient at being bad. And remember, a bad process is still a bad process. And remember, RPA does not equal AI. Okay, let's dig into machine learning next. Machine learning is a subfield of artificial intelligence, broadly defined as the capability of a machine to imitate intelligent human behavior. Now, it was defined back in the 1950s by one of the key pioneers, Arthur Samuel, and he said it was the field of study that gives computers the ability to learn without explicitly being programmed. There are four categories of machine learning. The first we'll take a look at is supervised learning. This involves training a machine and its algorithm using labeled training data and requires a significant amount of human guidance. It's one of the most popular forms of machine learning and is able to train models to accomplish tasks in classification, regression, or forecasting. In order to work, supervised learning requires a significant amount of human intervention because of its use of labeled data sets. Data must be divided into features, the input data, and labels, the output data. Spam detection is one application example. The next category is unsupervised learning. With unsupervised learning, raw data that's neither labeled nor tagged is processed by the system, meaning less work for humans. Unsupervised learning algorithms discover patterns or anomalies in large, unstructured data sets that may otherwise go undetected by humans. Unsupervised learning algorithms work by analyzing available data and grouping information based on similarities and differences, thus creating relationships between data points. Examples include automated customer and audience segmentation. With reinforcement learning, AI-powered computer software programs are outfitted with sensors commonly referred to as intelligent agents that respond to their surrounding environment to make decisions independently that achieve a desired outcome. Intelligent agents are self-trained by reward for desired behaviors or punished for undesirable behaviors. By perceiving and interacting with their environment, these agents learn through trial and error, ultimately reaching optimal proficiency through positive reinforcement during the learning process. Examples could be robotics, self-driving cars, and helping machines acquire specific skills and behaviors. Semi-supervised learning offers a balanced mix of both supervised and unsupervised learning. With semi-supervised learning, a hybrid approach is taken as small amounts of labeled data are processed alongside larger chunks of raw data. This strategy essentially gives algorithms a head start when it comes to identifying relevant patterns and making accurate predictions when compared with unsupervised learning algorithms, without the time, effort, and cost associated with more labor-intensive supervised learning algorithms. Examples here might be fraud detection, speech recognition, or text document classification. Okay, so that was a lot to consume, but it helps to have a basic understanding of machine learning and the key approaches. Let's now turn to another phrase you may often hear, that of neural networks. The human brain's neural network is a complex system of interconnected neurons that process information by sending electrical signals to each other. Signals generated by the brain's neural network travel through the nervous system to muscle cells, and these signals cause muscle contraction and motion, etc. In AI, a neural network is a method that teaches computers to process data in a way that's inspired by the human brain. It's a type of machine learning process called deep learning that uses interconnected nodes or neurons in a layered structure that resembles the human brain. Deep learning is another subset of machine learning that uses multi-layered neural networks, the combination of many brains, if you like, and are called deep neural networks. They attempt to draw similar conclusions as humans would by constantly analyzing data with a given logical structure. Another phrase I'm sure you've heard, and the key focus for much of the buzz around AI currently, is large language models, or so-called LLMs. This is actually a subdivision of natural language processing, NLP, the job of which is to understand and make human-like text. NLP is used, for instance, in the medical industry to decode doctors' handwriting and produce coded bills for patients. LLMs are trained with large data sets and they integrate with AI systems to improve language processing, task automation, and decision making. The most famous of these is, of course, ChatGPT and other AI models such as Grok from X and more recently DeepThink, the model behind DeepSeek. And this is where Gen AI or Generative AI comes in. Gen AI is probably something you have seen or heard about and I'm sure seen the results of. You may of course already be familiar with this and have been using it yourself. Gen AI is simply AI that can create new content and ideas, including conversations, stories, images, videos, and music. It learns from existing data to create new data with similar characteristics and improves its learning based on the outputs generated. If you've seen the plethora of realistic images on platforms like LinkedIn or Facebook, then you are seeing the output of Gen AI. If we dig a little deeper under the covers, we can examine the key types of AI. The first is reactive machines. They react to the current situation with no memory of past events. They always respond the same way to identical inputs. Next, we have limited memory. They can store a small amount of information from past experiences to inform future decisions and possess some level of learning. As we advance, we find what is called the theory of mind, able to understand the thoughts, emotions, and intentions of others, allowing for complex social interactions. This is still not achieved in reality. The aspirational goal of AI is self-awareness, AI that possesses consciousness and understanding of its own existence and mental states, similar to human self-awareness. Now we have an understanding of machine learning, neural networks, deep learning, large language models, and Gen AI. Let's look at what's emerging. AI agents. An AI agent is an autonomous software program that perceives its environment, processes information, and then takes action to achieve specific goals without human interaction. AI agents engage with their environment through sensors, APIs, or data inputs and execute tasks with minimal or no human intervention. Let me show you the 5 key types of AI agents. AI agents function through 3 main processes: perception, decision-making, and action. Some AI agents are reactive, responding to inputs without learning from past experiences, while others are proactive, anticipating needs and adapting based on historical data, particularly in areas such as fraud detection. AI agents are now being used in blockchain and crypto applications, for example. A simple reflex agent is a type that responds to the current situation based on a set of rules. Examples of reflex agents include vending machines, automatic calendars, thermostat systems, vacuum cleaners, and AI customer service agents. Useful in environments with stable rules and straightforward actions when immediate reactions to stimuli are sufficient. A goal-based agent is an artificial intelligence system that uses rules and algorithms to achieve specific goals. They are also known as rule-based agents. Goal-based agents use information from their environment to decide on the best actions to take. They consider future consequences to ensure their actions align with their goals. They also use search algorithms to find the most efficient path to those goals. However, they lack creativity compared to human thought processes and may have challenges solving unique and unfamiliar problems. Uses include autonomous cars, systems that help with workplace challenges, and systems that will help with complex tasks such as route planning. A utility-based agent is an artificial intelligence system that uses a reasoning algorithm to find the best outcome for a given situation. It's designed to maximize a specific utility, such as profits or minimizing energy consumption. They work by comparing different scenarios and their utility values, calculating the potential utility of each outcome, and then selecting the option with the highest expected utility. Examples include finding a flight with the least travel time, regardless of price, prioritizing investments to maximize returns, and optimizing resource allocation, patient scheduling, and treatment planning. These are just some examples. Utility-based agents can improve efficiency and resource utilization. They can also help prioritize tasks and allocate resources when handling complex tasks under tight deadlines. However, concerns include designing accurate utility functions, scalability issues, and ethical considerations. A model-based agent is an artificial intelligence agent that uses a model of the world to make decisions. This model helps the agent understand how the environment changes and how its actions affect the environment. Model-based agents are more advanced than simple reflex agents, which only react to the current sensory input. They use stored information about past states to make decisions. Uses include navigation, social interactions, and natural language processing, where agents can understand context and adapt to new information. A learning agent is a system that learns from its experiences and improves its performance over time. Learning agents are able to adapt to their environment, make decisions, and optimize actions based on feedback and data. Learning agents use sensory input to learn from their environment. They receive feedback on their performance and use it to improve their learning element, and can use a problem generator to design new tasks to self-train themselves. Learning agents can store information about their experiences, including successful and unsuccessful outcomes. Applications include gaming, healthcare, spam filters, autonomous vehicles, and more. Learning agents can improve decision-making, can improve productivity, enhance adaptability, and can enhance efficiency. I'd like to turn to the topic of agency now. Agency is the capacity to act, take actions, set goals, and make decisions that are aligned with achieving those goals. Agency is connected to consciousness and intentionality. Decisions are based on our desires, beliefs, and the perceived outcomes of our actions. Agency is giving someone the power to act without control or direction, the basis of empowerment. The attributes of agency are autonomy, ability to operate independently, making decisions without human intervention; intentionality, able to pursue goals and make decisions that are deliberate or purposeful; adaptability, capable of learning experiences, adapting behavior to new situations; goal orientation, to set and pursue goals and evolve those goals over time based on learned data. Another term that is now being used is Agentic AI, a type of artificial intelligence that can make decisions, take actions, and learn on its own. It is a probabilistic versus a deterministic technology that can both perceive, reason, plan, and act autonomously. This is known as test time scaling, and we'll cover that next. Traditional AI systems lack the capacity for true agency and follow strict guidelines, they're unable to deviate from their programmed instructions. However, agentic AI systems operate with autonomy, allowing decision making based on real time data, environmental factors, and learned experiences. Agentic AI is a system of models. It's taking the problem you gave it, breaking it down step by step, iterating through all those different models to formulate a response. Agentic AI systems ingest vast amounts of data from multiple data sources and third-party applications to independently analyze challenges, develop strategies, and execute tasks. I mentioned test time scaling on the previous slide, also known as test time compute. It's a strategy that allows a model to use additional computing power to pause, run multiple solution paths, reflect, and then refine its answer on the fly to improve the quality of its output, to reason more thoroughly. It's how agentic AI thinks. For the technical purists, there's a debate around agentic versus agentive. This is more important when looking at the overall framework and is not really important from the perspective of this presentation. But for clarity, let me define each of the terms briefly. Agentic tends to be back office getting the job done end to end, in the dark if you like. They call this backstage, what we might have once called back-end processing. Agentive tends to be upfront in the office with user interface interaction. They call this front stage, what we might have once called front-end processing. The joys of new terminology. One technique agents use is Retrieval-Augmented Generation, sometimes called RAG. Who thinks up these acronyms anyway? Retrieval-Augmented Generation is a technique for enhancing the accuracy and reliability of generative AI models, such as large language models, with facts fetched from external sources, like a research assistant looking for evidence they can cite. Large language models suffer from hallucinations. These occur when they generate incorrect or made-up information. This can happen when the model's training data is lacking or when it tries to fill in gaps with plausible yet incorrect information. RAG is therefore one approach to solving some of these challenges. It redirects the LLM to retrieve relevant information from authoritative, predetermined knowledge sources. If we couple this with the machine language training types we covered earlier, we are then able to develop the level of trust we have in the AI system. A word of caution here. Giving agency is equivalent to giving away power of attorney. Giving AI agency is giving it the power to act as you. One of the areas AI has the opportunity to be truly transformational in is physical AI. This is the use of AI programming in real-world machines that interact with their surroundings without human assistance or electronics inlaid in the ground, etc. This is made possible by augmenting the digital AI with capabilities that allow them to operate in the physical world. Sensors allow AI to observe the world and generate data to learn and improve navigation. Actuators cause or trigger a machine or other device to operate. They convert energy into movement. Manipulators give the ability to adjust grasping strength and position based on the type of objects being touched or handled. NVidia and others have created products that allow AI to generate virtual real-world simulations that allow the AI to learn and train itself to operate in the actual physical world. This means it does not need the physical world to learn and practice in. Once trained, it then becomes able to operate in that physical world, assuming the electromechanical technologies exist. The cautionary note for us all, however, is that the training speed and abilities will outpace humans very rapidly. NVidia claims that in the future, every factory will have a digital twin. Now let me show you a clip that was presented by NVIDIA and their partner Accenture at the CES show in Las Vegas in 2025.
Kion, the supply chain solution company, Accenture, a global leader in professional services, and NVIDIA are bringing physical AI to the $1 trillion warehouse and distribution center market. Managing high-performance warehouse logistics involves navigating a complex web of decisions influenced by constantly shifting variables. These include daily and seasonal demand changes, space constraints, workforce availability, and the integration of diverse robotic and automated systems. And predicting operational KPIs of a physical warehouse is nearly impossible today. To tackle these challenges, Kion is adopting Mega, an NVIDIA Omniverse blueprint for building industrial digital twins to test and optimize robotic fleets. First, Kion's warehouse management solution assigns tasks to the industrial AI brains in the digital twin, such as moving a load from a buffer location to a shuttle storage solution. The robot's brains are in a simulation of a physical warehouse, digitalized into Omniverse using OpenUSD connectors to aggregate CAD, video and image to 3D, LiDAR to point cloud, and AI-generated data. The fleet of robots execute tasks by perceiving and reasoning about their Omniverse digital twin environment, planning their next motion and acting. The robot brains can see the resulting state through sensor simulations and decide their next action. The loop continues while Mega precisely tracks the state of everything in the digital twin. Now, Kion can simulate infinite scenarios at scale while measuring operational KPIs, such as throughput, efficiency, and utilization, all before deploying changes to the physical warehouse. Together with NVIDIA, Kion and Accenture are reinventing industrial autonomy.
Wow, quite something, don't you think? Autonomous AI, sometimes referred to as superintelligence or similar, can analyze its own performance, learn from experience, and make adjustments to itself. The ability to independently program its own code, refine its own processes, all without direct human intervention. NVIDIA Cosmos is a platform to accelerate the development of physical AI systems, such as autonomous vehicles and robots. It offers a family of pre-trained models purpose-built for generating physics-aware videos and world states for physical AI development. It has already been trained on 20 million hours of video as of January 2025, and it is free to access via GitHub. This brings us to the final AI category, that of Artificial General Intelligence, or AGI. This is a dream for AI engineers and maybe the nightmare for the rest of us. A single system that can learn new tasks and generalize knowledge across domains without specialized training, that possesses common sense reasoning, able to learn and think like a human, adapting to new situations. One test might be that it understands irony. I hope this has been educational and informative, and has given you the chance to imagine all the possible applications where AI could be applied. It will also have given you cause to think about the risks, the ethics, and the shortcomings. One thing is certain, AI is here to stay. Uncertainty remains around how it will evolve and to what extent humans, us, will give it agency. My personal hope is that we leverage the machines to serve the humans. The principle of Jidoka introduced to us by the founder of Toyota. So thanks for watching, and in case you're still wondering, all the video elements of me in this presentation were AI generated.